Hello, Rojo. How are you?
Hi, how are you doing, Azules?
You want to go on a walk?
Yeah, sounds like fun. Look, pie!
This pie is mathematical. Well, you see here, if you look at this pie, you'll see Objective 48, identifying tangents, secants, and chords, and the properties of tangents. Here you see line AB is a chord, a segment whose endpoints lie on a circle, and points CD are the diameter. Line EF is a secant, a line that intersects a circle at 2 points. Point Z is a tangent, a line that intersects a circle at exactly 1 point. This shows theorem 11.1.1. If a line is tangent to a circle, then the line is perpendicular to the radius. This shows theorem 11.1.2. If a line is perpendicular to the radius, then the line is tangent to the circle. Nom nom nom. Roja, look, another objective. Number 49, applying properties of arcs and chords. Point J shows a central angle, an angle whose vertex is the center of a circle. Points BC show an arc, an unbroken part of a circle consisting of 2 points called the endpoints and all points in between them. Points CD show a minor arc, an arc whose points are on or in the interior of a central angle. Points FGH are a major arc, an arc whose endpoints are on the exterior of a central angle. Points GC are a semicircle, if the end points of an arc lie on the diameter. Points AB and BC, adjacent arcs, are arcs of the same circle that intersect at exactly 1 point. The measure of arc AC equals the measure of arc AB plus the measure of BC. This is an arc addition postulate, the measure of an arc formed by two adjacent angles in the sum of the measures of the two angles. This shows theorem 11.2.2. In a circle or congruent circle, one congruent central angles have angles chords. Part 2 of this theorem, congruent chords have congruent arcs. Part 3, congruent arcs have congruent central angles. Ew, what is that?
Looks like we have a mouse in the house.
Objective 50. Find area of sectors/segments. Well, if you look on this piece of cheese, you will see, ew, it's more. This shows a sector of a circle, a region bounded by two radii of the circle and their intercepted arcs, AX, AB, and BA. This shows a segment of a circle, a region bounded by an arc and its chord, arc AB and segment AB. This shows area of a segment equals area of a sector minus area of a triangle. Roja, look, it's objective 51. Find arc length. If the measure is in the interior, you multiply by 2. If the measure is on the exterior, you divide by 2. Hello, Mr. Conrad. Could you please help us out with objective 52? We do not understand it.
Too bad, guys. We learned this stuff a long time ago, and you should already know it. And it's on the test tomorrow, so I don't know what to tell you.
Azules, what are we gonna do?
We can just sit at my desk and I'll whip out my handy-dandy computer and we can look this stuff up.
Today I would like to show you a video about Objective 52. The first thing I will show you is DEF show an inscribed angle whose vertex is on a circle and whose sides contain chords of the circle. Next, we will talk about intercepted arcs. Intercepted arcs consist of endpoints that lie on the sides of an inscribed angle. Now I'd like to tell you about subtends. Subtends a chord or arc whose endpoints lie on the sides of an angle. DE subtends DFE. This is the inscribed angle theorem. The measure of an inscribed angle is half the measure of its intercepted arc, and this is case 1 for that theorem. This is case 2 for inscribed angle theorem. This is case 3 for inscribed angle theorem. If an inscribed angle of a circle intercepts the same circle or are subtends by the same chord, then the angles are congruent. This is shown by angle EB plus congruent to EA plus congruent to EB.
Wow, that was very interesting. Okay, Rojo, let's go.
I love math!
Get out of my classroom. By the way, good luck on the test tomorrow.
Roja, look on this baseball field. Objective 53. Find angle measures formed by lines that intersect circles. Angle AB shows if a tangent and a secant or a chord intersect on a circle at the point of tangency, then the measure of the angle formed is half the measure of the intercepted arc. The measure of angle ABC equals 1/2 the measure of AB. Points A, B, C, D show if two secants or chords intersect the exterior of a circle, then the measure of each angle formed is half the sum of the measures of the intercepted arcs. Angle 1 equals 1/2 the measure of arc AD plus arc CD. Snake, come out here. Happy birthday, Snake! Roja, I just realized our party hats show another objective. Number 54. Find length segments formed by lines that intersect circles. This is a secant segment. A segment of a secant with at least one point on the surface. Segment PM, segment NM, segment KM, and segment JM. This also shows an external secant segment, the secant segment that lies on the exterior of a circle with one endpoint on the circle. segment NM and segment JM show this. And this shows one theorem, secant-secant product theorem. If two secants intersect the external of a circle, then the secant segment and its external secant segment equal the product of the lengths of the other secant segments and its external secant segment. Example, AE times BE equals CE times DE.
I'm sick of your objectives and theorems.
Come back, Rojo. I'm sorry.
Okay, I accept your apology, but please
Stop with the theorems.
It's a bird. It's a plane. It's Superman. No, wait, it's just a plane.
Oh my gosh, it's a plane, and there's a girl with a dislocated knee, a circle knee on that plane. Roja, this reminds me of Objective 55, writing equations and graphing circles on the coordinate plane to solve problems. Here's an example, and how you would solve this is you would use the distance formula, which is x2 minus x1 squared plus y2 minus y1 squared over a square root. Then you add them all up and take the square root of the end result, and after you do that, you have the radius and the center point. Then you graph the center point and you go over in each direction how many ever the radius is.
I'm tired. Let's go to bed.
Okay, good night.
Azores, wake up. I gotta tell you about my dream. It was crazy.
Oh my god, I had a crazy dream too. We were in the
We're
forest.
just walking
Wait,
through the
what?
woods and it was
Wait, did we have the same dream or something?
I think we did. I am the ghost of the highway. I'm going to get you. No!
No! It's after me now! Run!
No, wait. I like your face. But now I must feed my children. Bye. What the heck was
What
that?
the heck just happened?